Welcome, pre-calculus. This is lesson 1.4. We're going to start off with example 1, which is going to look at increasing and decreasing behavior as well as constant behavior. So notice for increasing behavior, we always read our graphs left to right. So as I go left to right, my graph is getting larger. It's getting higher. My y values are increasing. So we say the graph overall is increasing. Whereas for this graph here in the middle, as we read left to right, always left to right, like you're reading a sentence, going left to right, my graph is decreasing because the y values are getting smaller. And in the middle here, while it is decreasing between negative infinity and x1 and between x2 and infinity, between x1 and x2, my y values are staying constant. So for this portion of the graph, I'm constant. And for the other portions of the graph, it's decreasing. So let's look at example number 1. It says use the graph of each function to estimate intervals to the nearest half unit on which the function is increasing, decreasing, or constant. So for A, when we read it left to right, my graph is going down, 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 always down. So for the entire interval, then the entire domain, we're going to be decreasing. So decreasing on negative infinity to positive infinity. This one is never increasing. And while it does kind of look like it bottoms out here and becomes constant, we know from our cubic functions that these are really small fractions that are getting really close to zero. And so it flattens out there, but it never truly becomes a constant function. It is always continuing to decrease. All right, looking at B, we're going to go left to right, always left to right. I am increasing from negative infinity up to right about here. Then it looks like I have a turning point, right? And then I'm coming back down. So I'm decreasing in this middle piece to my next turning point, and then I go back to increasing. So I would say we are increasing on, say, negative infinity to negative 1. And I'm going to union that with from 1 to infinity. Now, it's really important that you don't use brackets. When we're at a turning point, we can't say that this point here is either increasing or decreasing. So we never include them in our increasing and decreasing intervals. We're always going to have parentheses. And so the points in between negative 1 and 1, between here and here, we are decreasing. So it's going to be decreasing on negative 1 to 1. All right, go ahead and pause your video, see if you can determine where we're increasing and decreasing on the U-tries. Come back when you think you have it. Welcome back, pre-calculus. Looking at U-try A here, it looks like we are decreasing from negative infinity all the way to x equals 2. So one of the things that students often get confused with is they want to start saying, well, I'm decreasing from positive infinity to negative 3. We never give the y values when we're talking about our decreasing intervals or increasing intervals. Those are always the x values in which the y values are decreasing. So the x values for which my y values are decreasing is negative infinity to positive 2. And I never include it with a bracket, always parentheses. And then from 2 to infinity, my y values are increasing. So increasing on 2 to infinity with parentheses. All right, looking at B, it looks like from negative infinity to this point here, we are increasing. That point's negative 1, 2, 3. So increasing on negative infinity to negative 3. And then at 3, it starts to flatline, right? So we're going to be constant on the x interval from negative 3 to infinity. And that's it for example 1. Coming up in example 2, we're going to start talking about critical points and extrema, which are maximums and minimums.